then it's a big challenge for you, because this class needs a lot of time and dedication. Because this class is going to make a base. This class is going to make a base for you for the next classes you are going to study, whether you are going to Cisco track, you are going to networking track, or you are going to cybersecurity track. Whichever way you are going, you may pass this class. I am not saying that you may not be, because this class is not very difficult in order to pass. You can easily pass this class, but I don't know how much you get out of this class. So self-study is very, very important. So this chapter is on protocols. And here you can study about the protocols like TCP/IP protocol suite, and we have studied about the protocols earlier as well in the lesson. So these all are the things you can read here, or you can read in the book, or the reading pages what you have here available in the course. So you have chapter 4 protocol, and this is the PowerPoint. So I'm just showing you the PowerPoint. But if you read all the pages here which are available in the chapter, so you will get to know. Remember that in IP or TCP/IP only has 4 layers. Okay, we have 2 types of network layers. One is called OSI model, another one is called TCP/IP model. The 2 models are there. This one has 7 layers. This one has 4 layers. We are using TCP/IP model. So all the data instructions, layer number 765 are basically combined into one layer, then 4, 3, 2, 1 are some of one of layers are combined again. So total 4 layers are there in TCP/IP, whereas OSI has 7 layers. So here is the example of TCP/IP versus OSI. What OSI does, if you enlarge it a bit more, what OSI does and what TCP/IP does. So the comparison, side by side comparison. Now in these layers, how the communication works. So communication starts from application. It starts from application, goes to next layer, keep on going to the next layer, and every layer attaches some kind of additional information or takes some action on your data. So data starts from here, then goes to presentation, session, transport, network, data link, physical, and from here it starts again from the physical. So what the physical does, this physical will do opposite of this. Opposite. So here the physical is converting your data packets into a way or into a method where it can transmit it over the wire. So it is like bits are converted into current, because only the current can travel into the wire. Data does not travel. Remember one thing and fit this in your mind. Open your cap and put it in your head. Data does not travel. It has no legs. Data always travels on top of some other medium. Either it becomes a current or it becomes a light. So here, if it becomes current, because it is a copper wire, so it will convert it back from current to bits and bytes. If it is converted, if it is a fiber optic, then it will get converted into light. So it will travel and convert it back from light to data. Then it goes back again, data, whatever the data link layer provides some information here, it will extract that information and keep going. And application will receive the real data. Application will receive the real data. So if you look at the lesson, in the lesson it is explaining you how this information will get added to the data in every layer. How the information will get added into the data at every layer. So it starts with a data packet. So it starts as a data packet. This is my data. Then every layer adds some additional information to this data. Every layer adds some additional information to the data, and finally it becomes what it is?
Payload.
Payload. This payload goes into cable. This payload goes into the cable. Now, every packet has a fixed standard size. Now, it does not travel alone. This single packet does not travel. It always travels in a group of payloads or group of packets. 4 packets, 8 packets, 16 packets. It depends on your communication channel, what kind of communication channel you are using, and how much your receiver can receive at a time. It starts with minimum, let's say it starts with 4. Receivers receive the 4 and say, I can handle more, so it sends 8. I can handle more, 16, 64. It keeps on increasing the number of packets in one payload, and until the receiver says enough. So now that will become a standard between the two servers, between the two clients, or between the two machines to communicate over the network. Let's say you are talking to a person and the person was speaking very fast. So you may ask the person, hey, can you close a bit slower so that I can understand? The same thing happens in the computer network also. Your receiver decides how fast it can receive the communication from the sender. Okay? A lot of things are there. And you will see this structure clearly explained. I don't need to read everything from here. It is all explained in this lesson. So you will get an idea like how this IPv4 and IPv6 packets are generated or created. Where the data is stored in this packet, where the other information is stored in this packet, and how does it travel from one computer to other computer. And you can easily compare this. You can easily compare this with your postal communication. Postal. When you are posting your letter in the box, or you putting your letter in the box, it starts from there and reaches at the destination. You can compare it with this whole process, and you will realize that almost similar thing is happening here also, but the method is different. So that's all about just about the TCP. It is always connection oriented. Means until the connection is established, communication does not start. So it is my communication to you is not connection oriented. I am not asking, hey, are you listening to me? I am not asking again. I am not asking you to look at me, listen to me. It's all your choice whether you are listening or not listening. My message is like a broadcast. I am not asking any confirmation from you. Have you listened it or have you got it? Have you got it? Have you got it? No, I'm not asking. So it's all this type of communication called connectionless communication. No connection is established, no one-to-one connection established, but communication is happening. Such as Netflix, such as YouTube, such as all kinds of music apps, such as any live transmission happening on internet. It's all connectionless communication. It all depends on receiver, whether the receiver is receiving the communication or not. Receiver does not send the acknowledgement back to the sender. I received the communication. No acknowledgement is required. Whereas in TCP, it is connection oriented. Means a connection has to be established before the communication starts. Acknowledgement is required, is must. So every time a data is sent from one server to other server, here first of all connection, then data, and then acknowledgement. every packet, every data packet sent to the receiver must be acknowledged. If the acknowledgement is not received by the sender, sender will send the same data packet again. It will keep sending the same data packet again and again until it receives the acknowledgement or communication failure error occurred. It will not communicate further, but it has a particular number of attempts. It is going to make certain number of attempts sending the data packets and waiting for acknowledgement. Okay. Now you may say that, does it wait for every data packet? So it keeps on sending data packet and keeps on receiving acknowledgement. If one acknowledgement in between is missing, it knows that for which data packet the acknowledgement was missing, it sends that particular data packet again. Receiver will keep on receiving data packets. Once that data packet's over, last acknowledgement received, sender will send connection over message. Connection over message. It's like a walkie-talkie communication. You must have heard in or saw in various movies, or you might have get a chance to use that. They always say some name, then say over, then the other person will speak, say over, then they keep on doing that. Same way is TCP communication. It's connection oriented and acknowledgement based. Have you ever received acknowledgement for the letter you sent to someone? Always. But not always, but there are certain important mails you might be sending to your friend or family member where you need acknowledgement. So you can attach an acknowledgement receipt with the letter, and the person will receive this and sign it and send it back to you. That will give you an idea that the person has received the message or the box or delivery. In some cases, Amazon deliveries comes without any signature. They just throw it at your doorstep and left. But some deliveries comes from UPS or FedEx and they ask for signature. You need to sign. They sometimes ask for ID also. They need your ID and they get the sign. And so why that? Because they need an acknowledgement. And flow control is very important, which is basically controlling how many packets your receiver can receive at a time. It's like you open the tap. Initially it is slow. Water coming out is slow. You are filling that bucket. Now you say that I can handle more water in this bucket. So you open the tap more. So more water starts coming. Flow control is important in this TCP communication as well. Sequencing and checksum, that's what I was saying, that it always check the packet here. If it is received healthy packet, it will send the acknowledgement. If the packet is damaged, packet is damaged somewhere, so it will not send the acknowledgement, so that the sender will send the packet again. Checksums are usually for secure communication, where it is going to check the validity of the packet. So validity is like, it's always there code attached with the packet. There always be a code attached with the packet. It's like a string called a checksum. So what is the use of that string? To check the authenticity of the packet, because it started happening that using packet tracer or Wireshark kind of applications, people used to capture the data packet in between, add their own data in those packets and send. So this way they started sending viruses in the computers. So this checksum is there for authenticity. So sender is going to attach some special character with every message, and if anyone tries to change that message in between, this character will change automatically, or this string will change automatically. It does not matches with the real data.
the checksum a 1 or a 0?
Pardon?
Is the checksum a 1 or a 0?
It can be a bit. It's a byte, basically it's a string of characters, or it is a byte. It's a byte information. Now, how this byte information is created, that you have to check online, because there is another whole process of, let's say this is my data. So if I want to generate the checksum of this data, then I have to put this data in a process which will create a set of, let's say, 4 bits. 4 bits. A specific set of bits which represents the authenticity of this whole data generated by calculating the content of the data. Now, if someone modifies this data, then the receiver will generate this checksum again, another checksum. Now, this checksum, because it was altered, it was modified, so this checksum will not match with this checksum. If they does not match, that means the data was altered on the fly. While it was traveling from one to other, data was altered by someone in transit, when the data was in transit. Right? So that is the checksum. And checksum is very important these days. Earlier it wasn't the case. In initial days, there was no check on the data traveling between the two computers.
So when you receive the packet, then you would know if the checksum was changed.
Yeah, means if the data was altered, checksum is always there with the data, and you see it is like you put the checksum with the data, but is that checksum still valid? So your receiver is going to generate another checksum. Compare the new checksum with the checksum data attached with real data. And if it is matches, then the data is real, not altered. If it is not matching, it's changed.
So the new checksum is always going to be the same then?
It has to be same for original data. If it is not same, then that means data has modified. So it's like this. This is your sender. It is sending the data. This is the data, this is the checksum. So it is sending the data to the receiver. What the receiver will receive? Receiver will receive data and checksum. It is going to generate new checksum with this data and compare both. If it is matches, then the data is valid. If it does not matches, data is not valid. It works like that. Now these are certain transmissions between the two communicating devices. When the sender makes a request for the connection, it sends the SYN packet. Now I can see these packets in Wireshark. In Wireshark application, I can see these packets. So if the packet is titled as SYN, so it is a request for a connection packet. It's a response for request is SYN app, acknowledgement for connection. And the connection is established means just ACK or app. So these 3 steps are basically required for successful data connection between the two devices. Successful connection between the two devices. After the 3 initial messages, the payload or the data is sent. And then you have, so this is the three-way handshake process. I am making a request. It is returning the response, connection established. It is called 3-way handshake process of TCP.
It like adds 1 each time or something?
It is only when the connection started, and at the end you will send the termination signal. Once the termination signal is sent, then you have to start this process again. Obviously, the computers will do the same process again. If the website is open, and you are working on that website, you don't need to do this process again. But if you close the website, or there is a timeout, then you have to do the build process again.
Does it stop doing the process on its own, or you have to?
It is doing on its own. You don't need to do anything. Means you are not initiating. Let's say you are opening up Blackboard. So what you do to open the Blackboard?
Go to Gwinnett.
You go to the browser and you type the gwinnettech.edu / dashboard or whatever. So the moment you press enter over there, it is going to start this process. And then you get this. Now once, so it is going to make a connection. Server. Returning sync app. And it is returning app. Connection established. So here connection established. Now the link established between the two. Now the server, now you made a request here for dashboard. So server will receive the dashboard request here. Now server will send the dashboard data now. You are working on your dashboard. Once you close this connection, broken. Now you want to do it again, this will start again. In between, you are doing some authentication also, such as Okta. That comes later because you are basically logging onto your dashboard.
Or like a Google Passkey.
Yeah. UDP, that's what I was talking about, connectionless protocol. So if I ask you, connectionless protocol, so if I ask you your dashboard and your YouTube, you are watching, you are reading the chapter on dashboard or you are watching a video on YouTube. Out of these two protocols, TCP or UDP, which one is using what?
YouTube is UDP.
So YouTube will always use UDP, where dashboard will use TCP. Okay. Remember that all kinds of live transmissions are always on UDP. Any kind of database transmission where acknowledgement is must is all TCP. For example, you are checking your grades. Your grades are not on your computer. It is coming from somewhere. Your grades, are they only for you or for everyone? Only for you. So if it is only for you, then it is always TCP. It is always required acknowledgement, confirmation. Are you receiving the right amount of data, right data? If I'm televising let's say I'm doing live class, online class using Zoom. So do I need to bother about whether someone is joining or not? I'm not concerned. If I recorded a video and publish it on YouTube and ask you to watch, are you watching all at the same time or at different times? Different times. So when your communication is not, you do not seek any confirmation for your communication, then it is always UDP. When you are looking for a confirmation that I want to make sure that my receiver has received the right message, then it is always TCP.
What if you're playing an online multiplayer game?
Okay. It's a good question. When you are playing an online multiplayer game, do you need acknowledgement for that or not?
Yes.
Yeah. You do need an acknowledgement. So you understand by yourself what kind of communication it should be.
So TCP.
Right? Now, can I use TCP, UDP both in the same communication? Depends on what kind of data is flowing. For example, in case of, as you said, in certain cases, you are watching a video, but you are clicking or you are typing some chat messages also in that video while watching that video. You are typing chat messages. You can do live chats also while watching videos, right? So chat is using TCP while the video is using UDP. Okay. IP, so what is IP stands for? Internet Protocol. What it does, it manages the network. It manages the data. Means once this is your computer, this is your data leaving your computer. The moment it left the data, left your computer, it is now IP which is taking care of your data package and securely delivering it to the receiver. So it is IP's job to find the path, find the right and appropriate path between the two devices. It is the job of IP. That's the TCP/IP both works together. That's the structure of your IPv4 packet. So if you look at this picture carefully, I don't know, it is not enlarging beyond the limit. But this packet says data is sitting here. See that? Data is sitting here at the bottom, and on top of it you have lots of other additional information added to the data. And it all added because of different layers. Different layers of TCP/IP. So just study this. You can see all the, and its explanation is given here in the chapter. Okay, so you don't need to worry about it. It's very clearly described in the lesson. Then ICMP is Internet Control Message Protocol, which is basically used to report the success and failure of the data delivery. So whether your data is delivered successfully or not, that's the job of ICMP. ARP, Address Resolution Protocol, which is working on IPv4, and it is basically resolves the IP address and MAC addresses on the network, identifies and locate. So it manages the ARP table, IP to MAC address mapping. ARP table, IP to MAC address mapping. Is this IP belongs to this MAC address? There may be a possibility that one computer has two MAC addresses because of two network interface cards are there in one computer. This is one NIC, this is another NIC. So they both will have this different MAC addresses. They both will have different IP addresses, but the physical computer is one. So you need to understand, one application is using NIC1, another application is using NIC2. So now the data should be delivered at the right application. It cannot be swapped. The data requested by this application should be delivered to this application only, and that can be possible with the help of IP to MAC address mapping. If it is not happening, then data can be delivered either here or here because they both are in the same computer. So ARP is used for, and you can check the ARP data with the help of this command ARP-A. So very simple command ARP-A, and you can see IP to MAC mapping. See that? This computer has various other computers' IP and MAC addresses. Various other computers' IP addresses and the MAC addresses. That's your ARP. You can also check on your computers, on your laptops, that what information your computer or your laptop has. It may be same, it may be different.
How come yours has a lot more? Like mine only has less than that. When I do that command.
That's what depends on how many computers you are accessing from your computer, or this computer is accessing different other computers.
Okay.
All right. And it all depends on how this computer is making requests or connections to various other computers. Now the neighbor discovery, that is called NDP or neighbor discovery protocol, which is basically used with ICMP. So what it does, it's basically discovering what is the neighbor's information, such as this data for ARP brought by this particular application. NDP offers several ICMP message type given here and explained very well in the book. So read the book and you will get more idea about it. Ethernet. So Ethernet is the most important data link layer standard. That's basically standard made by the scientists, you can say, and is a part of data link layer. And what it does, capable of running a variety of network media. Ethernet offers excellent throughput at a reasonable cost and all that. Ethernet 2 is the current standard. So how one device can communicate with the other device, there must be some standards, and those standards are laid by IEEE. And Ethernet is named for those standards. So now the Ethernet 2 becomes a new standard here. Now the header all those standards are laid by this particular term called Ethernet, like what should be the data portion in the packet, what should be the MTU or the maximum transmission unit, means the largest size in bytes. What should be the size of the data, maximum size of the data, what it can travel in the network, whether it is physical LAN or virtual LAN. If the data size reaches up to 9,000 bytes and above, that is known as jumbo frame. And systems handle the jumbo frame easily. Some devices does not allow jumbo frame to pass through. Some routers or some switches does not allow jumbo frames to pass through. So in that case, devices does not use jumbo frames. Now, who decides that? So it's not us. It's not humans. We decide. We do not decide whether we want to use jumbo frame or we do not. It's all the applications. It's all in the applications uses or not uses jumbo frames. That's the picture of data frame for the internet. Okay, so ARP table maps the MAC addresses to what?
IP address.
We have two options in IP address, IPv6, IPv4. IPv4, let's see. Encryption protocol. So we have various encryption protocols and we call it CIA triad, and these three things are, it means in order to ensure these three things in network communication, encryption protocols are created. What is that three things? Confidentiality, integrity, and availability. Means whatever the data we are sending over the network remains confidential. Whatever data we are sending over the network, it does not change. And whatever data we are sending over the network must be available when and required. Alright? So the principles above from the standard security model called CIA triad. And your entire cyber security is based on these three things. Your data must be confidential, remain confidential, data's integrity must be protected at all costs, and data must be available whenever is required. For example, when you are opening your blackboard and checking your grades, what is your requirement? Your requirement is that your grade must be available. Your grade must be same across the session. If I open my grade today, if I open them tomorrow, they must be same. Same means if you scored X number of X points in one assignment, then it remains X throughout the sessions you are opening. And it is confidential, means Sam cannot see what Joe has secured. Confidential. So all the three things must be ensured, and the entire cyber security is based on these three things. So in order to ensure, we are using some encryption protocols. And there are various encryption websites available online which you can try. Okay. You can encrypt your data online. Okay, you can select your encryption type, and you can select you can type your password. So my password is passw0rd, that is my password. Today is Wednesday, and we can go for opening. And I say encrypt. So this is my encrypted message. Now if I send this message to someone, then I need to tell at least what was my passphrase and what was my encryption algorithm. So I use this encryption algorithm with this passphrase. So if I send this message to some friend, then I must tell that what was my encryption type and what was my passphrase. So this is like a private key, a secured key, no, not private, public key. This is like a public key. So without this key, your friend cannot decrypt this message, even the friend knows what was the encryption type you used. Got it? So you can try these type of websites and have some fun in your communication. So public-private key encryption, public key encryption, we talked about that. And we also use digital certificates. Digital certificates are nothing but the combination of these public-private key which are issued by certificate authorities over internet. So if you are doing a secure communication over internet, then remember that the encryption is managed by certificate authority, or we call it CA. There are multiple websites working online which are CAs, or working as an internet or certificate authority. So if you search for certification authorities, so you can find a lot of websites which are working as a certificate authority. You can check the Wikipedia for that. Then we have PKI, public key infrastructure, which is associated public key with certain entities. So basically, those public keys which are issued by certificate authorities are these. Then we have key management. Now, key management is a very important part in the entire encryption. If you are running a server, let's say you are the provider of encryption. So encryption services are managed by you from this server. So you will be having lot of keys on this system, and you must ensure that all these keys are associated with. So how does this server knows that GTC dashboard uses this key? GTC Linear Technical College, Lake Linear Technical College uses this key. Atlanta Technical College uses this key. So you have to make a list, or this is called database. So we are using some specialized key management software applications to manage those keys. And it is very important to use those kind of applications, otherwise it is not easy for anyone to keep track of all the keys. Then we have SSL or TLS and TLS, Secured Socket Layer and Transport Layer Security. These are the methods of encrypting TCP/IP transmissions. So both these are required for all kinds of encryption used for TCP/IP. IPsec is used for Internet Protocol Security, which is basically an encryption protocol suite that defines the rules for encryption, authentication, and key management for TCP/IP transmission. Now, when the IPsec is used, a communication channel, or basically it's added new communication channel in between, because see, this is your server where all the keys are stored. This is your server where the data is stored, and you are the client here making the request of this data. You are the client here making the request of this data, and there is another server which is working as authentication server, authenticating the client. So this client is making a request for the data from this server. Request for the data. So what the server will do, server will ask for the authentication details. Hey, provide me your user ID and password. So the client will provide the user ID and password. Server will check the user ID and password with the authentication server. If it is valid, then it will issue a token for this client to the server. Server knows that this client is valid or legitimate. Then, because the data is encrypted, it is requesting the decrypt key or decrypt the data from this server. So it is all communication happens in the network with multiple servers when you are doing authentication and encryption.
In order to get the security keys, you need a token.
Yes.
Okay.
You need a token, because server will send the token with that request that this client is asking for this data. So I need a key so that this encryption server will provide the required key which is designed for or created for that particular client.
Okay. So the authentication server is just there to make sure that it's okay to give the like two unencrypted.
So authentication server is basically verifying the client's user ID and password, and also checks the permission, whether this client is authorized to access this data. If the client is authorized to access this data, the token will contain all that information, which will be shared with this server to get the key for the appropriate data. Then we have remote access protocols such as VPN, such as RDP, such as Telnet or SSH. Those are the remote access protocol services, and you can use them. So, and remote file access to transfer the files between the two servers, secure, basically FTPS, which is FTP secure or FTP over SSL, SFTP, which is secure FTP, and TFTP, which is trivial FTP, which includes the no authentication or security. So it is the unsecured method of transferring your file. The other two are the secured methods of transferring your file. Now you may not be using these services directly, but behind the scene. For example, if you are uploading any file on Google Drive or OneDrive, if you are downloading any file on Google Drive or OneDrive, then these services are working in the background, and you will never get the direct access. But can I use these services directly? The answer is yes. You can use these services directly. You can have your FTP. So every Windows computer has FTP services. Every Windows computer has FTP services, and using these FTP services, you can send your files. Now here, get command is to download the files, and put command is to upload the file or send the file. Input and mget. Mget and input are to download and upload multiple files. M stands for multiple. So I can use these commands, and there is a command here called buy. Rest of the commands are quite similar to your Windows or DOS, basically Windows operating system command. But if I use by, I will come out of this prompt. Okay. SFTP you can use when you, but I'm not sure if SFTP is installed here. Yes, SFTP is also available on this computer. SFTP. Terminal emulation program. So terminal emulation program is basically those programs which provide you remote access of any server with the help of terminal. Means your terminal will emulate as you are working on a remote server. So it gives you a remote connection to a computer on your computer. Telnet and SSH are the two examples of that. Telnet is an unsecured application, and SSH is a secured communication. And these are some GUI based softwares which uses these applications in the background, such as TeamViewer, LogMeIn, VNC, some of those examples. Then your secure shell. We already talked about the secure shell, but secure shell is very important to avoid any kind of data compromising between the two servers or between the client and the server communication. So keep your data secure while in communication, while in transit. You can use SSH. So SSH is other type of terminal emulation programs are like RDP, which gives you a remote desktop, and OOBM, which is out of band management, used by some certain applications in the background. VPN, you have idea about VPN, and you can read more about it from the book. Some of the troubleshooting steps or tools, and you should all of you must remember these tools by heart. And very important is netstat. Netstat. Netstat displays the TCP/IP statistics and details about the TCP/IP components. So you can always use netstat command on your Windows computer, and it will give you a list of established connection between your computer and other computer. In this case, you can see the first column contains the same IP address. That is this computer's IP address. And in the next column, you can see foreign address. You can see some numbers also in front of those IP address, this number and this number. You see that? This number or some protocol name, such as HTTPS, some IP address, HTTPS. Number. So what are these numbers in front of the IP address? Anyone? No. Huh? Say it loud. Then? No. This is the IP address, but what is the next?
Yeah.
Port. These are the port numbers. So different services have always uses a different port number. So you may notice that all the port numbers here are unique, and they are connecting with a particular service. These are the service or the target location. Now notice these IP addresses. Remember anything about this? What are these?
Google? No, that's the loopback.
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 Someone will say loopback. So loopback means it is connected to self. It is connected to self. And all the other IP addresses you can see, IP address or MAC address and HTTPS. HTTPS means it is using HTTPS protocols to connect. So what it is giving me an idea, like if I notice, let's say someone is trying to hack into my computer, my server, so I will get the information here. If I do not recognize the IP address or the service which is established the communication with my server, then I can understand that this is a illegitimate connection. This is a connection which is trying to hack into my network, or which is hacked already into my network, and I can try to disconnect that connection. And in the state also you can say establish, time wait, sync, send, close wait, time wait. Read more about these signals. What type of signals are these? How many possible values are there? Right? In the state, are these the only values, or there are more values possible? So you need to know all that, because then only you will get the real picture of what is happening in your network. Tracer or trace route. These are the commands which you can use to identify if what is the path your computer is using to reach a particular website or reach a particular IP address. What path your computer is using to reach a particular website or IP address. Trace ERT or trace route. This is very useful. Now, you can't generally make these type of commands for public websites, because most of these websites block the response to these commands. For example, if you try to ping www.google.com, you won't get any response. So these are very common commands. Just to avoid any kind of cyber attack, these websites does not allow response to these commands. Okay, so you won't get any response from Google. But for the common IP address, let's say someone computer here, if you try to trace route, then you may get the path. How you reaches to that computer. Or if I try this IP address. Right, mostly websites does not allow. So first of all, it is going to this computer 10.10.180.1, and from there it is trying to find the path. But again, because maybe this network does not allow to use these commands. Who knows? All right, so tracer. Now these are the few commands, and TCP dump. TCP dump is a command which you can use to get the packet information. What packet you are receiving in your network, that packet data you can capture. But again, in order to analyze those packets, you need a special software. And you can find those softwares from online or internet. Wireshark is one of the software which can automatically capture the packets and also can examine the packets in your network. So if you have watched the video in the previous chapter about the Wireshark, you must have understood that what the Wireshark can do. Now, not everyone can use Wireshark in a corporate network. Wireshark can only be used by authorized person in a network, because Wireshark is capable of capturing the data packets from the network. So if two persons are communicating, their communication is encrypted and you are using Wireshark, that is by default it is illegal. By default it is illegal until unless you have the proper written permission from the organization to do the packet sniffing in their network. Packet sniffer. If you search for packet sniffer, you will get a lot of applications online.
Wireshark capture packets that are sent with HTTPS.
It can capture anything, any packet. Not, yeah, it can capture HTTP packets or any other packet you are sending, or your system is sending to someone else or receiving from someone. Okay. So sudo is required if you are using TCP dump. So you need to learn what sudo is doing in Linux. So it is important. See, for most of the cyber security experts, Linux is the most important operating system. So if you do not know Linux, then it is the high time to start working or start knowing more about the Linux. Otherwise, you will struggle a lot later. Okay? So for that, I would suggest you to download or create some virtual machine. Again, these days, VirtualBox is the most convenient software. It is Oracle VirtualBox. I would suggest you to take help from Google, YouTube to learn how to use Oracle VirtualBox. You can download the VM and add that VM to your Oracle VirtualBox and can use it. You can learn different operating systems with the help of virtual machines. And every instruction is available online for installing VirtualBox or adding virtual machine. There are two ways to do the virtual machines. One, you can do the pre-installed virtual machine, or you can download the operating system and then install on a VM. Either of those two. And there is a very nice virtual machine available for cyber security activities that is called CSI Linux. CSI Linux. If you get that virtual machine, you will see a lot of actions, lot of commands, lot of applications are pre-installed on that virtual machine. Alright. These are some solving common network problems which you may never encounter until you have in particular environment or you are working in real world. Because duplicate MAC addresses, how can you introduce a duplicate MAC address? It's not that easy. You need a specialized software to create a duplicate MAC address. So you just need to know, it is good to know that these kind of problems exist in the real world and what are the solutions possible for those problems. Alright, now you need to remote into a Linux server in another building on your network. Which of the following protocols should you use? Secure shell. Why not RDP?
Not secure.
Because Linux does not support RDP. RDP is for Windows. Linux is only supports SSH.
Why is it not VPN?
Why is not VPN? VPN does not give you a connection to a Linux server, but connects to a network. Remember, VPN is not connecting to a server. VPN is only connecting you to a network, and then you can connect to any server. Why not SFTP?
That's file transfer.
That is file transfer, not for remote connection. All four clear?
What does RDP stand for?
Remote desktop protocol. Right? So SSH.
I was saying for RDP 4333.
And yeah, by this point, you must know the port numbers of all these services. You can make a cheat sheet for yourself. If you are really a good learner, if you really want to do something in networking and cybersecurity, I'm repeating this statement again and again. Make a cheat sheet where you have all these service names and their port numbers in front of them. What is the default port number of RDP, Telnet, SSH, HTTP, HTTPS, FTP, SFTP, SFTP? All services and their port numbers should be handy for you guys. Experts can remember everything. You are new. I don't expect that, but one day you should all be remembering everything. Got it?
Yes, sir.
All right. Thanks for the day. Keep doing your work. Keep doing your good work, and then see you next week.
Yes, sir.